It's always something when you're adulting, whether it's,
Yeah. Yes, it
oh
is.
my goodness, just adding to the technical difficulties. I just got a phone call and it took over my AirPods for a second. Okay, I think we're live. And welcome everyone to this live stream on building agentic workflows with Mastra. I'm so stoked you could join us live here on Zoom. Here on Zoom, you can participate in the chat, you can ask questions and things like that. If maybe you're tuning in over on YouTube or on X or something like that, we won't be monitoring those conversations actively, but you can definitely still join the Zoom by following the link to the Luma, which is on the Mastra homepage right now. Okay, so workflows with Mastra. We're going to run for the next 40 minutes since we lost 5 minutes of technical difficulties. And we're going to tell you more about what a workflow is and how it's different from an agent. These are two different approaches to building agentic systems, and they get conflated sometimes. I think we can bring some clarity to that today through our description, but we're also going to be looking at lots of code examples as well. We're using a little TL draw here to give you an overview, no slides. We're going to get into the workshop and the examples so you can learn by example rather than just focusing on theory, but we will start here. You're going to learn how to build your first master workflow. We're going to look at some pre-written code, and Tony's going to walk you through each of the constructs and how they come together. As the workshop progresses, we'll look at some more intermediate type orchestration functions to do with branching, mapping, looping, and so on. We'll also, I think, have a little peek at some human in the loop stuff. Is that right, Tony?
That's right.
The best thing about coming to a workshop like this, as opposed to watching a YouTube video or something like that, is that it's interactive. If you have questions or comments, if there's something you want to get from this workshop, please use this opportunity to ask Tony your questions. I'll chime in where I can as well. I'll monitor the chat the best I can, but the best way to make sure your question gets answered is by using the Q&A tab. That presents it to us as hosts in a very tidy format where we can work through it methodically and make sure we get to the question if it's relevant to the workshop. You might be wondering who we are and why we're here on screen. Well, I'm joined by Tony. Tony is a founding engineer at Mastra, previously at Vercel and Next.js, as well as some other cool companies. And Tony, as I understand it, when I joined Mastra and I had a bunch of questions about workflows, you were the person I went to because you are one of the brains behind the feature. And so I'm really excited for people to get to learn from the source, as it were. There's no one better to learn workflows from and ask questions about. We're focusing maybe a bit more on the getting started side today in terms of our examples and things like that. But if you have more questions relating to your implementation or maybe some advanced questions, don't hold back. I'm sure we can answer you as well. My name's Alex. I'm your host today. I focus on developer experience at Mastra. So that's a broad umbrella, which means if I can make your life a bit easier with the product, maybe that's through SDK improvements, maybe that's through documentation, maybe it's through education, right? Such as workshops like these. I also contribute to the Mastra YouTube channel where I make videos about concepts and tutorials relating to building AI agents in TypeScript. So you can check that out if you want. By the way, this little note got cut off, but to reassure you and set you at ease, we will definitely be sharing all the code you see today in a GitHub repository. This session is also being recorded should you need to drop off or you want to watch it back later. If you signed up via Luma, you'll get an email at the end of the session that will include a link to the YouTube video. And in that YouTube video's description will be a link to the code. I'll also paste a link to the code in the chat as we progress here. So before we jump into the code, I'm going to quickly give you a definition of workflows. That way we're starting from the same place. I'm going to give a fairly high level overview. And what I'm really excited about is seeing these kind of abstract examples in the form of a whiteboard come to life in code. You'll see more what I mean about that as the workshop progresses. So what is a workflow? An AI workflow is a system whereby large language models are orchestrated through predefined paths to complete well-defined tasks. The number of steps and the stopping conditions are fixed and fully controlled by you, generally resulting in more predictable and consistent behavior. So we have large language models. They're this incredibly powerful technology, and they are non-deterministic, which means you can give it the same input 10 times and you'll get 10 different outputs, whether that's a simple prompt or you're running some kind of autonomous agent. That is very, very powerful when it comes to open-ended tasks because an agent can find its own way to the outcome. For example, a coding agent takes a very general task to do with a brand new code base and some new requirements, and it will figure out the best way to get there. But it might take some wrong turns along the way, right? If you've ever used something like Cursor, you'll know that sometimes it goes off the rails a little bit and misunderstands you, or maybe it's overzealous and makes too heavy changes. And sometimes it just gets stuck in a loop and never finishes. When we think about using models and leveraging them to build AI powered applications, sometimes agents are a bit too non deterministic. We want a bit more control about the path that the workflow takes to achieve this outcome, but we still want to harness that power of a large language model. And so here are a few examples to give you an idea. I think the best way to understand this is with some examples. For example, you might be coding a meeting summarizer application. You might input a transcript into your workflow and use a large language model to summarize the transcript into decisions, actions, items, owners. And then once you produce the transcript, you move on to the second step, which is to email the notes to the attendees. The first step here could leverage an agent. It could use something like 4.0 Mini to summarize the transcript, but there's no need to use an agent to email notes to the attendees. We could run a step in our workflow that uses an API like SendGrid or Resend to do that. And so we're kind of harnessing the power of a large language model for this step, but we're running deterministic procedural code for the next one. We're mixing and matching to get the best of both worlds, and we're getting a fairly predictable output here because this task that we delegate to the agent is very focused, and so it's less likely to go off the rails. We are in control. We determine when the workflow ends, which is once these two steps have completed. Another example of a workflow might be to categorize support queries. So I think when we think about agents, we often think about AI assistants. And a really popular, well-known example of an AI assistant is a chat support AI assistant. If you have a problem with your Amazon order, or maybe you have a support inquiry for some B2B SaaS you're using, you might go back and forth with an agent. But these agents are very difficult to implement. And a lot of businesses actually are reluctant to put these agents into production because if they go off track even just a little bit, that could be really dangerous for their business because it might take some action it shouldn't, provide some wrong information. That's very difficult to adopt in external facing agents. And so oftentimes when we think about harnessing the power of LLMs, a company or a service provider thinking about how to offer better support to their users, they might use a workflow instead, where they get some of the benefits of an LLM, but all of the power of being able to predefine the path to complete the task. And so maybe a support query comes in via an email, and the workflow uses a fast, efficient model like 4.0 Mini to quickly categorize the incoming support query. If it's something very simple that can be answered from a knowledge base, then maybe the workflow moves on to this step where it uses an agent, maybe a different agent or a different model, sorry, like GPT-5, which is a bit more sophisticated, has better reasoning capabilities to generate a response from the knowledge base and send it. If, however, the support query is a bit more nuanced, maybe it's to do with private data like billing or something, this will all be determined by the agent system prompt. You might start a support email thread and put this user in touch with a support agent instead. We're using an agent, we're using a model to categorize, and we're using an agent and a model to generate the response in the case that it's a simple query. But we also have this option to run deterministic code to start a support email thread. And as you can see, we define the whole workflow up front. There's sort of predefined paths that you can take. This stops, compared to an agent, which can take any number of routes, with a workflow, it takes one of these paths. And using workflows in Mastra, as you'll come to learn in this workshop, you can do branching to do different things based on different conditions. Another slightly more complex example, one I'll just run through very quickly because I love this example, is that of an AI code review tool. If your team is using something like grepDial or one of those other pull request code review tools, we don't know how they're implemented, but they could conceivably be an AI workflow where they fetch the pull request with all of the changes and comments and things like that. They categorize the files, find relevant files. Maybe we're only checking source code files as opposed to config files and things like that. And then it might run a series of steps in parallel. The linting step might just run deterministic code, running some local process. But maybe these two steps to do with checking the style guide or checking the security issues, these might happen using an agent. And when they all finish running in parallel, eventually the workflow will do some comment using a GitHub API. And so I think this illustrates how we combine the power of the agent with the non-determinism of code to implement successful AI-powered applications. Something that comes up a lot, and it's a very valid question, is about the difference between agents and workflows because they have similarities and it might not always be obvious when to use which, honestly. And that's a very fundamental question when you're building an agent because it will inform the approach you take to implementation. I previously made a video comparing these two, and the reason I wanted to pull it up quickly, apart from just to let you know this exists if you want to go deeper, is because I made this table sort of comparing how they differ and where they each thrive. And so, like we touched on, workflows are better suited to well-defined goals. They follow static paths. They have a fixed number of steps as defined in your workflow. And this is the key point here about autonomy. Sometimes when people describe AI workflows, you'll hear them described as agentic workflows. And the idea here is that agency is not a binary thing. It's not that something has agency or it doesn't. It's more of a spectrum. And we can probably agree that if you're just writing TypeScript, that's pretty low agency because you predefine every step. There's no thinking happening. But when you get into the territory of workflows, like that first example I showed you with a meeting summarizer, this is somewhat agentic in that it can reason, in that it can take decisions and do things without us being explicit about the instructions. But it's not as agentic as, say, a coding agent or a deep research agent or something like a computer agent. That's where things get to be more high agency. You can implement workflows that pull together different agents with different scopes of responsibility, and you get closer to this sort of end of the spectrum to do with high agency, but it's ultimately a spectrum. And what we're describing here when we talk about workflows is somewhat of an architecture or an approach to structuring your agents. It's really going to be up to you to determine what you're trying to build and the right way to structure it. And to help you do that, we offer Mastra, which is the TypeScript agent framework. Specifically today, we're going to be talking about workflows. This is where you get to bring those diagrams I was showing you to life with real code, with real models. And to teach you a bit more and show you how it comes together, I'm joined by Tony. So, Tony, how about we jump into some of the code? And in the meantime, I'll keep an eye out for any questions people have so I can jump in and make sure we deliver as much value as we can in the next half an hour or so here.
Sounds great. Let me just set up my screen share here. So hopefully you should all see my editor right now. How's the font, Alex? Is it looking good, or should I zoom in a bit more?
It looks nice. Yeah, I love it. Go full screen if you can, but no worries if you're.
I'll be switching windows quite a bit.
Yeah, switching windows, exactly.
Let's leave it here. All right. So first we'll look at code just a little bit. So we're going to go through like a series of examples here. I've prepared 5 different workflow examples for us to demonstrate some of the basic building blocks and how to put those together. So at the root of every Mastra project, usually it will be under the Mastra folder in an index file. If you follow the usual conventions, there will be a Mastra class instance. And this is the home of really all of the Mastra primitives, all the workflows that you want to be accessible and callable over HTTP or with like the client SDK libraries, all the agents. There's some storage involved. We'll see why that's very useful later on, but this allows us to store certain things in different databases. And then certain like observability configurations so you can really understand what's going on. Now, before we actually dive into any workflow code, and we're actually not going to spend as much time in code today as you might expect, we'll run a Mastra dev here in the project, and that will boot up the Mastra Studio for us. And I'm just going to open this link here. I actually have it open already. I'll go into the workflows tab here, and you see all of these workflow examples that I had open in the editor just now. So everything that you register in the Mastra instance, whether it's your agents or your workflows, those will all be here for you to play with and see what they are. And this is our first example for today. It's a quite simple starting point. We have a workflow with 2 steps that run in sequence. one that fetches the weather forecast for any given city that you pass to it, and then one that plans activities based on what the weather conditions are for that location. You also see there's a form here on the right-hand side, which is asking you to fill in the city to get the weather for. So let's go ahead and do that. We'll do that for, let's say, Helsinki. So you see where we fetched the weather, that step has succeeded. And we are currently planning some activities, and that has succeeded now as well. And there's another tab here on the left called observability. So let's see what that's about. So you see that this workflow has indeed been run one time, has completed successfully, and two steps are a part of this workflow run. Firstly, the fetch weather step, which took in something like this. It's an object with the city filled in as a property, and it outputs an object with some weather conditions, like temperature, whether it's going to rain, that sort of thing. And then the second step being the plan activity step, which takes in that weather information and produces this kind of activity plan here. There's a 100% chance of rain, so better bring an umbrella if you are where I am at right now. And you can also see some interesting information about any agent calls and like specific LM calls that might be happening inside of this step here. So in this case, there's a GPT-4o call. You can see all the token usage related to those, as well as the overall token usage of the workflow itself. So let's see what this looks like in code, shall we? I'll open up the editor here again. This is our first example. So every workflow starts with a call to this create workflow utility. And this is what you can import from Mastra core workflows along with create step, which we will see soon enough. And the ingredients to creating a workflow are you need to give it some sort of a name or like an identifier of sorts. It has an input schema and an output schema. Now these dictate what is the values that you plug in. And it's a structured input sort of a value that you plug into the workflow. And what is the actual final results like? So in this case, we plug in an object with the property city, and this looks very familiar from what we just saw in that observability tab in the studio. And it produces this activities object, which we also just now saw in the studio. So if we take a quick look here again, this is what the input to our workflow looks like. And again, the output of this is that same object structure that we just saw in the code. Now, how does this map to this little form that we had here? Well, this exact label here, the city to get the weather for, is in fact the description of this property here in the object. So if we were to add more properties with more descriptions, then that form would have more fields for you to fill out to run that workflow. Now, those two steps that we saw in the studio, the fetch weather and plan activity step that run in sequence, those are found here. So when you create a workflow, you can add steps sequentially by saying .then. So the first step is a sequential single step in the workflow, which fetches the weather. And only after that step has finished, do we then plan the activities for that particular city and weather conditions. You then, at the end of it, have to commit the workflow, and that will ensure that you will not add any further steps into it, so we can build whatever the internal representation of that workflow is going to be. If we look at the code for the first step here, similarly to creating a workflow, you create a step using a utility function, and you have an ID, input schema, and output schema. Now, all the master primitives have optional descriptions as well, and these are what show up here under these step IDs here in the studio. So interestingly, you see that the input schema is the same shape as the input schema of the workflow. And the reason for this is the first step in a workflow takes whatever input the workflow receives as its input. It then produces a forecast schema as its output. That schema you can see here. So this is that exact object structure that we saw in the observability tab, which has the temperature and weather condition information in it. And then most interestingly, there's an execute function that you attach to a step. And this is what actually dictates what happens when you run the workflow and when you run this particular step. So in this case, we only have one argument here to the execute function, which is the input data. And you see that this basically corresponds to whatever is the shape of what that step takes in. Now, the code of this step is actually not the most important thing. What we basically do here is just use this open media weather API, and we plug in the city from the input data. and we get a bunch of information back, and then we distill that to this forecast format that we had, and then we return that at the end of the step. Now, interestingly, if I were to, let's say, comment out this one field of max temperature, we see that there's an error here on the create step call. And the reason for this is maximum temperature is actually missing from what you say that this step is going to return. And this is one of the reasons why specifying the correct schema is very important, because you need to be able to like put all these pieces together and be sure that you have all the information you need. So being able to make type safe steps into your workflows. Let's put that back. Now that error is gone, so we should be good to add the step into our workflow. So this is what we return, and the next step was a plan activity step. So then logically, the input schema of this next step is going to be the same forecast schema shape as the previous step returns. So the data always flows from the previous step to the next one. Or again, if it's the first step, then it flows from the workflow inputs to that first step. And since this is the last step in the workflow, the output schema of this step also matches the final output schema of that workflow itself. Now, the execute function here is a little bit more involved. It has that same input schema variable, and it has now a different shape, the shape of the forecast schema instead. And then there's a Mastra parameter. Now, what's the Mastra parameter? Well, at the very beginning, we saw this Mastra class instance here, and every workflow step has a reference to this variable. So you can access all the other primitives and features that come along with Mastra. So in this case, what we do is we get an agent from the Mastra instance. We prepare a prompt for that agent. In this case, we plug in the forecast information, and we plug in the city, and then we stream via agent.stream the entire text chunk stream of that agent call. We put that in standard out, but we also accumulate it and return it in the shape that we want to return from that workflow. Now, where's the city come from? Because actually in the forecast schema, there's no city in it. Well, there's a third parameter here called get init data. This is like a convenient tool for you to access whatever is that very first input to the workflow in any step, because it's very common for you to have some additional configurations that you might not even use in that first step, but you want to use them later on. Or maybe there's multiple steps here, like in this case where the city is needed. You don't need to propagate the city all the way through the different steps in the workflow. So putting that together as a prompt, if we run that example again, let's say for Austin, now that we're planning the activities, here you see actually the process std.write in action, running that plan for us. That's pretty much all there is to the simple use case.
Nice. So what's the advantage, if we just stay on step one for a second, what is the advantage of using Mastra's create step function here and create workflow function, as opposed to having just a code file that does one thing after another without a framework?
A lot of advantages, I would say. One of them is all of the steps can be retried automatically. So if there's anything that goes wrong, let's say in this agentic step here, like maybe there's an API issue with whatever, like whatever LLM provider you're using, the step will be automatically retried based on some retry configurations that you can set in those steps. You will see later on different benefits from using different tools for human in the loop interactions. So you can suspend the execution of your workflow and then resume it later on. You can also, let's say something happens to your server, you can resume the execution of your workflow when the server comes back up potentially. You can also do things in parallel quite easily, which you will see later on. Yeah, I think there's loads of benefits. One of them is the type safety of doing things like kind of block by block. And another, of course, is being able to see everything that's happening and being able to plug things together.
Oh, I like that point about being able to see things, because right now we're looking at a CLI output and we're looking at Master Studio, which is an interactive development environment. Tiny Talk has a question. They ask, how do you connect that to your front end? And can you send custom update chunks back to the client while the execution is still in progress?
you can completely customize everything that's sent from any of the steps. So there's actually like another parameter you could add here called the writer. And using this writer, um, well, that's kind of a weird update to do. I think you can even do something more structured here. Um, let's say something like that. And as long as you write this, this will show up in your stream as well. It will show up as a workflow step output event in your workflow stream if you're streaming the output of your workflow. So you can do any sort of custom updates of any kind through this mechanism. Um, and then yeah, as far as how you integrate this into a UI framework, I would say the easiest way, that's not really part of the workshop, but let's see if we can whip something up here quickly. So there's two ways to run a workflow programmatically. One is using start, and this promise only resolves once the whole workflow has completed. But you could also do stream, in which case you will get back something where you can actually like do a four-way const chunk of this, and then this is where those events will show up. Now, if you're using this with, let's say, the client SDK, all of these events are something that you can render with whatever UI framework you use. There's also different like AI SDK transformer tools that we have. I don't know if we really have time to get into those, but maybe we can send some documentation to those afterwards.
That's a great idea. Raphael asked, what if they have 4 steps and they want the output of step 2 in step 4? Do they need to propagate that data through step 3? Or is there a way to get step 2 output in step 4? That's interesting because you can get step 1 input anywhere. But what if you want to get the output of a previous step in a later step?
There is a way. We'll actually see that in the next example, I believe. So maybe we can cover it in a few minutes.
Oh, perfect segue. Yeah, let's do it.
All right, so let's look at the next one here. It's based on the same principle and the same code in some way, but slightly more involved here. So
Can I
we
draw
have
one quick
another,
parallel, Tony? When I
yes.
drew those diagrams in TL Draw, I was trying to resemble the Mastra Studio interface. So if you think back to those abstract workflows, now you're seeing, although it's a different example, I think you see it coming to life, which is really cool.
Well, there we go. So a very similar example here. We start by fetching the weather. We give it a city. But then we see this little branching happen to these two when blocks, and you see that there's a condition attached here. So if the chance of rain is more than 50%, we end up in this branch here. And if it's at most 50%, then we end up in this branch. Now this plan activity step is the same as before. So if I was to run this with Helsinki and we saw the chance of rain was very high, it's going to end up in this new branch where we plan indoor activities instead of outdoor ones. So again, if I go to the observability tab here, we see there's a fetch weather step, which looks exactly the same as before. However, now we have this plan indoor activities thing, which only gives you indoor activities independent of like, as long as the chance of rain is more than 50% or like at least 50%, then it's only going to give you indoor activities in this case. Normally, it would give you at least some outdoor activities as well. And again, here you see the LLM call information. And then now here, actually, you have this mapping step. So if we go back to this, there's this weird little box here, which I haven't named. So it has like an automatically generated name, but it is a mapping of sorts. Now, if we look at what that does here in observability, you see that it takes as input this object that has a key plan indoor activities, and then it has this activities object as its value, and it produces an object with just activities. Now, it's going to make more sense if we look at the code, so let's just do that. So this is the weather workflow for this example. The same setup here in terms of what the workflow should take in and produce. Starts with the same first sequential step, but then instead of a .then to plan activities, there's a branch. And a branch takes an array of these tuples where the first value is a condition. Now this is that exact same condition that you saw in Studio before. And if the chance of rain is high, then we run this plan indoor activity step. Otherwise, we plan the usual, multi-activity plan. Now, that branch, since actually these conditions don't need to be mutually exclusive, It could be that both of these are run at the same time, in which case they do actually run in parallel. Or it could be that only one or even none of these get run. So what that branch returns as its output schema is in fact not just that object with the field activities in it, but it looks something like this. It's like a record where every key is like the ID of all the steps that are part of the branch. And then their values are those steps' respective output schemas. In this case, they do happen to be the same schema, but they need not be the same schema actually. So here, because our workflow needs to produce just this object, not this one, all we do is we map the result to be this like activities object. And where does the value for that come from? It comes from the activities value of either this or this step. Now, there's other ways to map this. You could also do a function that resembles um, an actual like step execute function. So you could do like an input schema here, or input data, sorry, here. And then here you could like actually access those individual step schemas. So there's like a function called get step results that you can
So
use.
this is like a transformation, basically. If you want to
Yes,
transform the output of the previous step into a new shape for the next step, map is the right tool to map and filter, basically.
indeed. So what we could do here is we could take the results of the plan activity step and the plan indoor activity step, and then we could manually check whichever of those is defined, or we could return both of them or whatever we wanted to do. And now the map doesn't need to be the last thing in the workflow, but here you could do, you could even return the output of that very first step, fetch weather
There's a good
or
question here from
whatever.
George who asks, when building AI chatbots, would you go with an agent or with a workflow and branch based on different paths?
That depends very much on your use case. So if you start with a workflow that branches, you introduce a lot of determinism. So if that is what you want to do, then that may be the right choice for you. What it also means is that the inputs that you plug in to that workflow, they're always structured, right? You plug in some kind of object, or I mean, you could plug in a string and then have an agent as the first step. But perhaps if that's what you're going to have to do, it might be better to have the agent be the entry points. And then that agent may call the workflow, in fact, or it may do something else. And we will see that example later on as well.
Yes, that was a good question from earlier that I've missed, which was about um, asking if you can combine workflows. And it's really
Yes,
interesting, isn't it? Because you can nest workflows, you can even wrap up a workflow in a tool, so your agent can call it. All of these primitives can interact.
indeed. And that's going to be the next example, in fact, is how to combine workflows.
Awesome. We're at 10 past the hour, Tony.
Mhm.
Um, so I think we should run for another 10 minutes or so. How does that sound?
Sounds good. So just one more thing before we move on to the next example. So this map construct is not just something that you can call at the end of the workflow. You can in fact call it anywhere that you want to call it. It can sit between any steps. So if you wanted to modify whatever output, let's say the fetch weather step produces, you could have a map here. And then the result of this map is what actually gets plugged into these steps here in the branch instead of this output. So you can really use it to transform one output to another kind of an input, or you can also use it to transform that final result of the workflow. It's really up to you where you need that, where you need to use that. Like if you have, let's say, two different kind of workflows that share some of the same steps, but they don't fit exactly together in both those cases. Maybe in one it does, but in the other it doesn't. You can always use map to kind of glue things together nicely.
Rupesh
But
asked if we can integrate Mastra workflows in a Vercel AI project where they're currently using the stream text function of Vercel already. Um, how can they integrate workflows with that project?
uh, I think that also depends a little bit. So, I mean, you can plug in like AI SDK models into Mastra. That's in fact like kind of the main way that we do that. So if we look at some of those agents used here, let's see, for example, the planning agent that we are using.
I think they're
This is actually,
specifically talking about the stream format because AI
okay,
SDK UI doesn't recognize master workflows, right?
yeah. Yeah, so there's like a transformation layer that takes workflow events and then it turns them into something like AI SDK compatible. where everything is like a custom UI message. Um, I think we have some docs for that as well, so maybe we can try and run those up at the end.
In what way does map differ from step?
Map is really just more of a convenience if you want to map one thing to another thing. It's a little bit less verbose than a step is. If you use map with a function, it's also not exactly as type safe as a step because with a step, you specify exactly what input and output you expect. But then map as a function does not. If you use that object syntax that we have here, then this is type safe because we know what the schemas of these things are, but it limits you just to mapping whatever comes from these steps in this path. So it's a little bit more limited than using that function. I would advise if you do anything except something super simple to always use a step. And if you use a map, then to try and prefer this syntax as it is more type safe.
Beautiful. Should we move on to the next example?
Yes. So this is basically the exact same example that we just looked at, except instead of planning indoor activities, if the chance of rain is higher, the conditions here are a little bit different. It's based on 20% instead of 50. But this step here is in fact a workflow itself. So there's 3 steps here. And interestingly, you see like these 2 dangling entry points. There's not just 1 step, but 2. And then they kind of come together in the synthesize step here. So let's see what this does. Again, if it rains, we're going to end up here. So I'll just click on Helsinki because you can see it's raining. Um, so you see here that the plan both workflow is a step, but it also has these sub steps that are running. And this step only completes after all these 3 steps have run. Now that we've synthesized all the information, we go again to that same mapping step here. And looking at observability for this, we have the same fetch weather stuff. We evaluate conditions. And then based on the condition, we pick to run this plan both workflow step, but that actually runs a workflow run itself. And it runs a parallel of 2 branches, plan indoor activities and plan activities simultaneously. And then it runs the synthesize step. And this value that it takes as inputs looks quite familiar, I'm sure, because this is exactly the same schema format that that branch had, except now both of those activity plans are here, and then it produces some kind of a combined report of those. Let's look at the code for that here. So again, exact same weather workflow, except here we have a plan both workflow instead of a step. And this is actually just the workflow itself. There's no create step here because the workflow and the step have the same interface. They both have input and output schemas, and it doesn't have an execute function, but what I call like the flow description of the workflow. This basically tells you what that execute function is, right? What you need to do to execute that workflow as a step. It needs to run all these steps. So why we had those 2 dangling boxes, those 2 entry points, is because we don't start with the dot then, we start the dot parallel. Now dot parallel takes an array with, in this case, as many steps as you want it to run in parallel. Here we have the plan activities and plan indoor activities steps running concurrently. And we then, only after both of those steps have completed, end up in this synthesize step, which as its input schema takes that record format with both of those step IDs in it, their respective output schemas. We then, using this Mastra instance, take the synthesize agent, use agent.stream, but the prompt is now a combination of both of those input values from those 2 steps that ran. And we ask it to kind of put together an overall plan based on these 2 different alternatives. And again, the same deal, we go through all the text chunks from that LLM stream and then output those and then accumulate those so we can return that at the end of the workflow and then map those into the shape that we wanted to return. And this is how you can combine workflows. Another example, just to kind of speed up a little bit here.
Sorry, Tony, I'm going to use this opportunity to ask a couple of questions. There was a question about if it's a good idea to have a big object to pass data from step to step and add new data to each step so it can be used in all steps. I think they're basically describing like aggregating an object. Or should you only have the necessary input and output schema and keep it as lean as possible?
I think in general, you should try and keep it as lean as possible. If you have scenarios where all the steps need something that's shared, if it's not a part of that initial input of workflows, We do actually have a new feature for workflows called workflow run state, which lets you have something that's like more global to the execution of the whole run itself. There's actually some docs shipping for that this week. It is already live, so stay tuned for that one. But otherwise, you do always have that tool at your disposal that we briefly saw earlier, which was to use this, um, oops, this little get step results mechanism here, which lets you basically plug in any step and this will return what was the output of that step.
Okay. So that's how you'd get step two
Yeah,
result in step four, for example, like
yes.
someone
So if
asked
it's like
earlier.
more occasional that you want something from one of the steps that passed, then I will use this. So you don't need
Christian
to pass
asked,
the context along all the time.
Christian asked if we can dynamically build the list of steps to be launched in parallel. That's a great question, I think.
You can, yeah. So I mean, here all the workflows are built kind of statically, but what you could also do is you could have, let's say, I don't know, you make an API call to some whatever API. It's just something random that doesn't really exist. But point being here, you could actually call like, I don't know, let's say that it's an array of things, then you can map over that. And then for all of those things, you could actually call create workflow
Oh,
or
nice.
or it could be like a create step. And then this is what you actually like plug into your workflow as the steps, right?
I love that.
Or like you can really build anything you wanted as long as you commit at the end of it, it does become runnable. And
Oh,
we
that's
actually use
amazing.
that internally in Mastra quite a bit as we construct workflows fully dynamically and then we run them.
So I'm not sure if this is already the next code example, but with only a few minutes left, I would love to see a human in the loop example. And maybe
Yeah,
you
let's
can
do
touch
that.
on, you teased, Tony, you teased us. You said at the start, you pointed out storage and you said you'd
Yep.
come back to storage. And I'm really
This is where
interested to learn
we
more.
this is part of the part where we or this is part of where we come back to it. The other part is I'll just mention it right now, is all this observability stuff that we see here. This is all based on storage as well. I keep restarting the server, that's the way it goes away. But if we were to run this example again, um, then all of this stuff of like, what we were looking at of how the runs actually progressed, what was the input and output values at each point, this is all saved in storage as well. So this is why you're able to see all the information after the fact. Another reason, many, why it's very useful is going to our next example here. This may look like a downgrade in terms of complexity, but just wait for it, it's not. Um, Similar structure, we have one parameter here. We need to give it some kind of description of a vacation. Let's say that I want to go to the beach, which I rarely do, but there it is. It's going to generate some suggestions. There's some kind of a human input here in between, and then we do a travel planning at the end of it. So let's run this. So we have some suggestions. Wow, that's new. You can actually see 3 suggestions here, and you can see that the workflow is now suspended. And there's like this little pause icon here and this human input step. And we ask for a selection and then to resume the workflow. So let's pick Bali, I guess. Click on resume. Aha, so now the human input step has finished. This stays the same as it was before, and we're now doing some sort of travel planning. So if we look at the observability for this one, interestingly, you see there's 2 entries here. So let's look at the first one. We run this generate suggestions thing that runs a travel agent, sort of an LLM thing. So again, takes the vacation description, generates those suggestions that we saw. And then here you see that this next step of human input, it gets those suggestions, doesn't return anything, and it has suspended status.
Mm.
Now looking at the next entry here, we start at the human input step. And it now does have an output, which is the selection that we made. We then run that last step, which gets that selection and creates a travel plan. So looking at the code for this one, again, 3 sequential steps, inputs and outputs look exactly like they do in the observability section. Generate suggestions is now using generate on a master agent instead of stream. No other difference, except we want it to return like a JavaScript object structure instead of text. And we want it to be an object with a suggestions array that's like objects with locations and descriptions on them. So then we can just return that object directly to the next step. So in the next step, we can get an array. Then on the human input step, We have an output schema, that's the selection that we saw, but there's two new schemas here. We have a resume schema, which is, that actual selection that the user makes. This is what we saw in the form. And it has a suspend schema, which has that shape that we saw appear. If we were to quickly run this again, you see that this shape here matches that suspend schema. And then the selection of the user comes from that resume schema description here. So what's basically happening is we have a couple new parameters to the execute function in play here. We have the usual input data, of course, but then we have a resume data, which can either be undefined, it can be that object with selection string in it, which is that resume schema shape. And we have a suspend function, which takes in a payload, which again is in the suspend schema shape. So what we do in this step is we check if we have a selection from the user. So if the resume data is defined and there's a selection, or sorry, if there is not one, then we suspend the execution of the workflow and we pass in the suggestions that were generated in the previous step. However, we do have that selection. We just pass it forward to whatever is the next step, which in this case is planning the activities for that trip using, again, generate call, then taking the original weather description, the vacation description from the workflow's initial inputs, taking the selection from whatever we passed from the human input step, and then that gives us that final step.
And do suspended workflows consume resources while in a suspended state?
They do not. And this is where one of the other reasons why storage specifically for workflows is very interesting is when you suspend a workflow, the execution actually stops. And this is why in the observability tab here, you see two different entries because these are essentially two different runs of the same workflow. So when you suspend, what happens is at this particular point in time, we take the whole run state of the workflow, the state of all the previous steps, all the inputs of this particular step, and so on. And we snapshot that into storage. So you can come back in 10 seconds or 10 hours or 10 days or 10 years, even theoretically speaking, and then
Yeah.
resume the execution of that workflow as it
Yeah.
were at the point that you suspended it. So it's like a point in time snapshot of the entire workflow execution state.
Finally,
But
Tony,
actually,
can you please show us that code example where you run the workflow manually as opposed to, because there's a good question here about, how do you reference the suspended workflow? And I think that might have that this might be the
yeah,
key where you show how to
let's
reference the
see.
workflow
Let's see
graph.
if we
Yeah, here we
can,
go.
because it's actually a little bit outdated, but let's see if we can quickly whip something up here. And this example also doesn't really exist anymore. Um, let's see, step 5. And then this one takes in, actually, let's take one of the earlier ones. First one, and then let's simplify into run.start. Like that.
Well, you typed, Tony, I'll just answer Rupesh. You asked about if you can, when steps are in parallel, um, what, can we have steps from in parallel where the number of steps will depend on some condition, like the number of files a user uploads? I think the answer is yes, because you can construct the workflow using code. And so you could do that in a loop or
Yeah.
whatever, right?
There's also another way, which we didn't go over, but there is a construct called .for each. And .for each
Ah,
takes an array of, it basically takes, like, as its input schema, it takes as an array of anything. And then the step that you plug into for each will take the individual items. So it's kind of like a for loop, if you will. So there could be like a iteration step, and this takes one single item, but for each as a whole takes an array of that item type. And then you can
I'll link
also
to some
adjust the
docs, Tony.
concurrency as well,
Oh, yeah, that's a nice
concurrency argument.
option.
So you can run 10 simultaneously.
Oh my God,
Um,
I have my own question. How's that different from parallel?
it's different from parallel in the sense that for each depends on from the inputs of the for each. So whatever you return from the previous steps, that will be an array of however many items in it. And then that is the base for your parallelism. Whereas parallel, you give like just a number of different steps to run, right? So for each runs the same step, but over a variable kind of size of argument or variable sized array of arguments. But then parallel is different steps rather than the same step multiple times.
Nice.
and the inputs are the same for parallel.
Thank you, Tony.
So
Should we just close
back
out
to this
that? Yeah,
example, just
exactly.
to show the so how you would then do like if you wanted to resume it, it would basically be like this. So you start a workflow, you pass in the input data, which is that familiar shape of passing a city, and then as soon as it's done, we can print out the results. If the state is that it's suspended, then what you can do is on that same run object, you can call resume and then passing the resume data that you wanted to. In this case, there is no suspend in the workflow, but to illustrate the point, you can pass in whatever resume data you wanted. You can also pass in optionally a resume step because this workflow can also be suspended multiple steps at the same time. And if that's the case, then you need to tell the resume command which step you want to resume specifically. If only one state is suspended at a time, you can just resume without that argument. And now if you don't have this run object like on hand, you can always create it again, actually. So what you could do is like, uh, you can pass in a run ID. And as long as this comes from, like this run ID comes from some external system or something you generate and store somewhere, then, using this same run ID, you're always going to be resuming that same specific run instance of that workflow. So that's kind of in a nutshell how the resuming would work, programmatically speaking.
Beautiful. Thank you so much, Tony. And thank you so much, everybody, for tuning in. There's a few more good questions in the chat I would love to get to, but we are already over time. I think, yes, really appreciate your time, Tony. And thank you again, everyone, for tuning in. I'm sharing a link to the code and the recording in the Zoom chat. So maybe you joined late and you want to watch from the beginning, or you just want to reference some of these code examples so you can go more in depth. This will be a great resource. You can also check out the Mastra YouTube channel where I've created a couple of videos on workflows. I have a video on parallel and a couple on human in the loop. If you like learning from video, that might be up your street. And for all your other questions, hit us up on X. You can DM me or you can post at Mastra. You can also join the Mastra Discord channel. Sorry, I don't have a link handy, but you can find it referenced on the website. And that's probably your best way to get a nice, tidy support thread. And we can help you with any of your questions. And not only that, I mean, when you ask a question, it can sometimes feel a bit like you're the one benefiting, but we truly benefit from your questions because when we see where the questions are and the gaps are, well, that's an opportunity for us to make the answer more clear, either with docs or guides or SDK updates and things. So we welcome your questions. I hope to see you in Discord and I hope to see you at a future Master live stream. We host these every Thursday around this time, give or take half an hour, and we dive into different topics conceptually. So maybe I'll see you there. And one more time, Tony, thank you so much. It's been such a pleasure.
Thank you. And if I may take 10 more seconds, there's a fifth example, which you might want to look at. This is how to like loop based on a condition. And also, I just wanted to show you real quick how you could create an agent that has a workflow as a tool. It's
Tony,
truly
I would
that
listen to
simple.
you for another 10 minutes, mate. So take it, please.
It's truly that simple. If you want to have a workflow as a tool, we automatically wrap them if you just plug it as an argument or as a parameter into a workflow like this, to an agent, sorry, like this. You can plug in as many workflows as you wanted. Based on the description, the schemas, and everything about the workflow, the agent will just figure out how to use it and what it's for. And that's it. That's my last thing.
There's a link to Discord, and I think that's our Discord. Janelle generously shared the link. Thanks again, everyone. We'll see you next time.